Hello, welcome to Live Coding with Gerph. So this is a live session where I'm going to be coding some tests for a disassembler. Hopefully I'll manage to get through some of that process today. I'm not expecting a huge amount of excitement out of it. It should be relatively easy, I hope, but we'll see. So what are we trying to do today? Let's have a quick look. So last time, here's the test output we were looking at. I've got lots of test output where things have said it's different. So I'm scrolling up it now. Right, is that the beginning? No, it's not the beginning. Here we go. Oh, lots of bits. Right, here we go. So we got through a number of these bits and found that there were some bits that were, yes, managing to pass here. This is excellent. There's some bits here that I'm liable to need to change. So this one here looks like it's a different address. I need to find out what that address is because that's an odd one. Is that in the system heap? Might be in the system heap, I'm not sure. So this is one difference that we can just fix up and just say, yeah, that's fine. It doesn't matter. And we've got a bunch of these tests that we fixed up last week, and they are now coming out correctly. But then there's some that are not coming out okay. So here we go. This one's saying it's running a different thing. And I think this is all related to differences in how the build service and the local system works. So I'm going to have to do something a little bit clever with this one, I'm sure. But I'll have a look into it in a minute. And these ones, now this particular test goes and tries to run some thumb code and tries to disassemble it. And the differences are not that significant. So here we've got MOVS rather than MOV. So MOVS is being returned by the capstone debugger, whereas here we're returning a MOV. It's a little bit different, but not terrible. It'd be interesting here to see what the RISC OS Classic debugger does, so we can actually compare to that, because that might be the way to go with that one. And then these ones we've got here, it's managing to decode a little bit of extra information. Not going to worry about that, but it's giving us a yield here. That's correct. Undefined instruction. There is a defined undefined instruction in thumb. I don't quite understand that, but yeah, but apparently that is a thing. Weird. So the actual thing about these MOVs is that I've used these to mark the difference between the transition between different sections of the code. If we actually have a look in here, so if I find the code here, debugger thumb code, we should find the source file. There we go, thumb code. So this is actually what's going on here. So we've got the special code, the branches, load and store instructions, arithmetic, and so on. And each of these is a different type of instruction. So I'm trying to group them together. So there's a number of them here that are a little bit different. Things like these, CBZ, that's a check and branch of 0. And that's actually going to an address, not to it's not a constant, so it's a relative value. So that one's one we can try and fix up. Although actually looking at it, that looks like the minus means that it was in the old version. That's capstone is producing the odd value, and this one's and ours is producing what looks like a sensible address. So that's good. I'm quite happy with that. And again, some of these are just reporting different values. There's nothing that looks like it's actually reporting a distinctly different value, so that's good as well. Right, so having looked at some of this, what we're going to do today is we're going to go and have a look at making this code closer to the original, closer to one another, and then just accepting the changes as they are. So what we have is in the expect directory, expect thumb code. I think this is one. Yeah, this looks like it. This is what output is expecting to see. So we can just transfer things over to the expectations and just say, yes, that is fine, and see the differences between them. So Oh, that one's not going to work. Hello world. It tries to dump a file. That's not going to work because we haven't got the hello world file. Let us move that across so we've got it. And these init stores seem to hang. Not sure why that was, but we'll have a look and have a see what we can do about that, because maybe that's a thing we can fix. In fact, probably it's because it's just got way more memory than it was expecting. So I can probably just change the memory size and that'll help. Okay. So with that in mind, let us start attacking some of this. Yeah, so some of it's just capitalization being different here. So tiny little differences there that I just need to try and harmonize between the two parts of the system. So it's something like this. It's like, yes, the old version in Capstone produces hex value by default and we generate the decimal value. And in this debugger, we produce it the other way around. Not a big deal, just the way it's being done. Yeah, so, excuse me. Let us start from the very top and see what we've got in here. So the first ones here were this utility module. I think actually I'm going to go and just comment this one out because it's not actually producing the same results, and that makes it a bit more difficult. I'm relying on something else in the system. So Rayans said, do I work on the project on the stream only? Yes, unless there's something that's not related to this particular project, like the build system not working, I work only on this project in the stream, and I don't do anything outside of the stream. So everything is recorded pretty much of what I've done. Oh, there was one exception where I was literally just converting code to be C89 format, and I did a good chunk of that offline because we'd already seen it, but there wasn't anything particularly special on that. Okay, so comment out this particular error test here. So if you look in tests.tool, test.txt, test debugger then. Debugger Pyro. Here we are, this one here. Right, so I'm looking for the utility module. Utility module address, so that one there, the unaligned one was coming out wrong. Why is the unaligned one coming out wrong? I'm not sure, but I'm going to just mark it as being ignored. Skipped, not relevant. Or skipped, not working. No, disable, that's how we do it. Disable, not working. Oh, hang on. Oh, I see what's going on here. This is not... What's happening is the old version was rounding it down and we're not rounding it down. So actually this is an easy one to fix. I can fix this one quickly. Let's do that now. Let's do that now. This is the star memory I code. So if we have a look in C/memory I maybe. That'll appear quite a bit, won't it? Is it disassemble stuff? Here's the function. And probably what we should do is we should just make it similar to the instruction size. Instruction size here is this. Actually, this is a constant. It should go out the top here because I'm going to want to use it. So here we go. There's the instruction size. And what we should do is round the start address down. Start address equals start and not inst size times 1. Which is true, so it is always going to be a multiple of 2 for ARM, Thumb and ARC64, so that's okay. Is that all right? And then the end address, yeah, that looks okay. Start is less than address. So what's the difference between start and address? Sorry, I misunderstood this. Start is the start address is start 0. If start is less than address, Oh, we should be using address then. That's all we should be doing. Yeah, so I shouldn't have put this here. I should have put it just here, so it's after we've done all the roundings and everything. Yeah, there we go. Right, so we try building that, and then we can run this command. Let's give that a whirl. Okay. RISC OS ammo, build it. We only want to build one version. We don't need to build multiple versions of it. Ooh, wildcard resolve. Well, that's interesting. I'm in test code. I think I've left a bit of debugging in one of my scripts. A little bit surprising. I'm not. Is it going to do it again? No, it didn't do it this time. Okay, well, that's almost certainly part of the build system. Or is it part of ammo? I don't know what generated that. I'm not going to worry. Right, common functions, load module debugger, and then run the command we want to run. This is the command that we were trying to get. And you can see that it's at trying to disassemble 405, and hopefully it'll start from 404. There we go. Okay, that's better. It feels like we're actually achieving something and getting something done. 10 minutes in and I've changed one line of code. Whoa. Right. Oh, that was my size optimizations, wasn't it? I better commit that as well, hadn't I? Right, let's commit that. Commit. Use the generic size optimization. Makefile system includes functions for definitions for optimizing with different assemblers, compilers. Use this instead of hard coding the switches. Okay, so that'll fix that. And then the only difference we've got left is the instruction which says should we commit. Oh, hang on, I need to run my test as well. Make. How did we run the tests? Test equals star memory I. That's the one of the ones we want. Yes. Come on, do you? Oh, I'm in the wrong place. There we go. In fact, these are the tests I want to be running, I think. And this takes a little while because it needs to send it to the remote service to make it work. Yeah. Yes. So at Arctic, I've been building my disassembler, as Ryan says. And it's going okay. There are still problems with it, as you're seeing, but this is coming to the end now and we're doing testing and it's getting a little bit better at this. Well, that's interesting. Look, we've got some slightly different output because it's telling us that it's the offsets of code and things. I think we can accept that as being the correct how is it going? Yeah, it's going. Sorry, yes, it's going quite well so far. Right, so we got this bit. I think that's a valid set of changes. So I think I'm going to go and commit that change. Still got that lowercase LSR in there. I'll worry about that later. Dum-dum-dum-dum. So let's see. So the one that's related to memory I, which one was it? Utility up this one here. Yes, we're going to accept that one as the correct change. So that one there. And have a look. That should show us that is now the correct output. All right. Yeah. Commit all that. Fix for star memory I at unaligned address. Not rounding down. Now round down. Ooh, round down when the star memory I address is not a multiple of the instruction size. Yeah, that sounds good. This means that we won't be disassembling things that are never instructions. Oh, instructions. Okay, that's good. All right. So the next thing was this big list of differences on the star memory IT. So let's have a see what we get here. I want to see if we can. So here's our test. Come on, where's the test gone? Here. So this is going to load the test code and then disassemble it here. Oh, this is the copy. I can just load it from below, can't I? Actually, what? It's Debugger here, isn't it? Ooh. I'm thinking now. Yeah, that must be right. Is that right? Yes, that must be right. Sorry, I'm a little confused. So Ryan's asked about using different tiling window managers. So most of the time when I'm actually doing this stuff, I will Alt-Tab between windows. But if I use Alt-Tab here, there's a real danger that I'm going to switch to a terminal on another screen, and a different workspace. And so I'm not doing that. So I can just Alt-Tab between them like this. That's just Command-Tab to switch between the two applications, but I tend to not do that. I don't really like tiling window managers, although I have this set up so that I can use up and down here. So I've got them just set up that way around to be aligned for me. But because I'm wanting to have a lot more visible for you guys on the stream, I've had the windows a bit bigger and overlapped. I've got on my system here, I've actually got, this is one display. I've got a second display that's over on the right that shows the browser. I've got another window over here, which is the reference manuals, and that's on my main laptop display. And then below that, I've got another two vertical windows that you can't see, which are one for me to view the stream and questions from people, and one that would normally be code and the like. So I would normally be looking between different screens, but because I'm having to pack it all into one screen, it's a little bit more condensed. So that's kind of why. I've spent many years working with different environments, and most of the time I just haven't really got on with the tiling window managers. So yeah. Artix asked, have I ever tried to make my own programming language? I have, but I'm not very good at it. I've written lots of processing systems that do variable assignment and translation and things like that, and loops and stuff, but I've never written a proper programming language because that's all very complicated, and I leave it to people that are cleverer than me because I'm not that clever. I've written a lot of different processors of things, but that's not the same as a programming language. Right, sorry, I've forgotten where I was up to. Right, so yes, here we are. This is the output we're getting from this debugger. What I was going to do was use the RISC OS Classic debugger and see what it comes out with. So let's have a go at that. So if we do that, common load module projects RISC OS Pyromaniac modules debugger. So this will give me the debugger module, and I need to do some configuration. So I think I need to make config memory map memory map 0 page enable equals true. I think that's what I need to do to make that work. Yeah, feel free to talk to people about what you're working on. That's very happy with that. And hi to Dave as well. 0 page enable, and then command line. I can do the same command, can't I? I can do this load and execute. Load the code and execute it. So I'll see whether this works. Might do, might not. Ooh, badness. Yeah, that's the low memory warning. How do I turn that off? Because you're not meant to write to these low addresses at all, but the old classic module does. It uses some nasty memory collusion. Hang on, what do I do? So pyrodev help config less. Oh, give me the help, please. Traps, not swide traps. Trace points. Trace points. No. Oh, this is stupid. What the heck are they called? Am I going to have to just... I wrote the blooming thing. I can't remember how this works. Config foo equals... There we go. It'll give me an error telling me what the different region section types are. And I can have a look. 0 page. That's a possibility. Watch regions. There we go. That's the one I wanted. Watch help config watch regions. Low vectors. Is it low vectors? What was the actual failure label? In low memory, it was described as. So if I do dot foo again, it'll go and suggest that I have a name. Oh, this is being... Oh, it's not help config, it's just config. Maybe I should get to print out what the setting is to change this. Low memory, there we go. So I go back to my command from before and do config watch regions dot low memory equals no. So disable the traps on that. Artix created himself a nice programming language that does emulates assembler, which is quite nice. Always fun to be able to try and get those things working. I'm not very good at that. If you want to post your links to the projects you're doing, if you want, feel free. I don't mind a little bit of advertising on here for things like that. Well, this is interesting because it's coming out quite different. Yeah, it's coming out quite differently because it thinks these are different types of instructions. Interesting. This M65, I believe, is undefined instruction. Yeah, it looks like that. Okay, so we've got the output. So now let's go and write this to thumb classic. Okay. And then what we can do is we can compare it to our thumb code and see how well we're working. Right, so now the code we've created here, do this as thumb alone, and yeah, that should be okay. And then we can have a look at the differences and see whether this is going to work. No, not work. How similar we can make it. It's really interesting that this comes out as an LSL 00 R0 number 0. And in the other case, it comes out as a MOVs. It's interesting that. I wonder if... Let's go to thumb instruction LSL encoding. LSL immediate, thumb instruction set encoding, and ARM and that's at university. So it's either going to be this one or this document here. Let's have a quick look. Aha! Left shift immediate. Encoding in thumb 1 is 0000000, immediate 0000. So that's kind of interesting. But it says that if immediate 5 is 0, then see MOV of a register. Ah. Yeah, that's not the one I want. Although, interesting. Data processing. Opcode 0 comes out as a... Oh, I'm confused now. I thought that... Yeah, a little bit confused at that. Oh no, opcode's there. So yeah, it's not data processing. It's one of these. Yes. So all of that is a logical shift left, immediate. Oh, which is taking me to the same page. Okay, fine. But this says see MOV, which is interesting. MOV of a register. MOV of a register. There we go. Yeah. So there is no specific encoding of doing that in... Oh, that's for thumb 2. Encoding in thumb 1. T3? I thought it was only thumb 1 and thumb 2. I'm clearly out of touch with these things. Encode, or maybe that's just different encoding labels. Right, so what it's saying here is this is actually the zeros followed by zeros there is the encoding of MOVs there, and MOVs is actually apparently the correct way of expressing that. So that's interesting. It means that the assembler that we've got is actually doing slightly the wrong thing because it's not reporting it as a MOVs. Don't know how easy that would be to fix because we'd have to change the decoder, but I could do that. It's not a problem. And this here is actually, this looks like classic debugger is coming out with the wrong answer. On the other hand, it's possible that RISC OS 5's got a slightly different form. I'm using the version from Select, and yeah, not necessarily the same. Interesting actually to grab the one out of RISC OS 5, wouldn't it? It would be kind of interesting. Can I do that quickly and easily? Possibly. Possibly. Probably, actually. Come to think of it, yes. So let's just grab that version. RPCMU. Oh, except I don't have a RISC OS 5 RPCMU. Okay, in which case then RPCMU 5, and we'll run it this way. And that's exits. Right, screen showing. And then connect to, oops. Yes, sign in please with the default password. Come on. Did that not connect? Did I do something wrong? Not sure. There we go. Right. It's fired up. Right, still starting up. Programming, please. Surely we have a zap on here or something. Surely. Utilities. Text. Zap. There we go. One zap. It's thinking about it. Thank you. Right. Create, get module, debugger. Right, there we go, got a debugger module. Just need to save that out now so I can use it. Where are we going? Ryan says, is that your version of Templos? This is RISC OS 5. This is the operating system that I'm working towards, or part of anyway, a variant of. So save this. It's a little bit more than Templos, thankfully. Although Templos is an incredible achievement. There you go. Right, there's the RISC OS 5 debugger. We are now done with that. Kill that. Go away. Go away. Go away. All right. Now we can try running this again with debugger RISC OS 5. This will almost certainly RO5, and then this is thumb RO5, classic RO5. This will probably break. I'm gonna bet this will break. Hasn't broken yet. Ooh, no matches. That seems like a crash. How badly did this break? No such file or directory. Oh, yeah, because oh dear, wrong directory. I want the one from this directory, please. There we go. Try again. Everything's running a little bit slow today. I'm not sure why. I'm sure there's a good reason. Okay, let's have a look at the file. Ooh, there we go. Right, so we've got some slight differences here. Ooh, yeah, some slight differences. M00 difference. Let's just compare those two files. Thumb, classic, and thumb, classic RO5. Come on, up you come. Whee. Right, so RISC OS 5 version understands this breakpoint instruction, whereas the version that I've got at the moment doesn't. This one seems to decode that as a branch. This one decodes it as an M00. Don't know. This one's got it as a BLX. Okay. Ooh, got some oddities here, but yeah, R13 rather than SP. Yeah, it's not a big deal. How are those different? Oh, the slight differences in the output formats. The select debugger isn't outputting top bit set, but the RISC OS 5 debugger is outputting top bit set. But there's nothing else in the instructions that are much different. So I'm going to just ignore it for now, since it's the same sort of thing. But this LSL is quite interesting because it is, I believe, wrong, or not quite the same thing, because this is a MOV instruction. So yeah, that's neat, because it means that ours is actually disassembling right. Kind of right, because it's got the MOV now than the MOVs. Anyway, part of the bit that's going wrong here is that we've got this LSL when it should be sorry, not ASL. So the one, our output is this one up here, isn't it? Which I've lost here. So what we should be having is mobs, and these ones here should be EORs, ORs, adds, and so on. They should have an S on the end of them. So I think the best thing to do is actually change DARM to have the right things in it. So in order to do that, I have to find out where it's getting adds all of those values from. So the source code for DARM is here, not Armadillo. Armadillo is a 64-bit version. DARM, it's probably in one of these tables. One of the fun things about DARM is that Dave says that one of his colleagues told him off for saying EOR. It's EOR. Ryan's asked about information about the project. Which specific project are you meaning? Is the are you meaning the RISC OS projects or the Debugger projects? There's a lot of sort of differences, different projects that are involved here. I mean, so my operating system disassembly is the disassembly is just this as you've been seeing it. But RISC OS itself, there's a lot of pages on RISC OS Open Code UK. Anyway, yeah, so that's where you'll find things. And Alan said, how on earth are you supposed to mount EOR? In a lot of platforms, it's XOR, so actually the X character. So that is a little bit odd, but it's always been EOR for, I think, since the BBC days, but other platforms went with XOR. It's like Gerph saying water. Water. Oop, that wasn't the button I meant to press. I keep forgetting if you click on the background, a backdrop in modern macOS, it goes and flips all your windows away. And so you get to see my kittens, or my kittens, my parents' kittens. It's like, look, it's sitting on the window looking out on the ledge. Very sweet. Anyway. Yes, I'm surprising you with unexpected kittens. That's the way things go. Normally, I've got a little thing here called Hidden Me that ensures that the background is in purple instead. So behind this, you just get a purple background. Partly because that encodes better and ensures that there's no additional things there. But yeah, I didn't turn it on today, so we got kittens. Woo! Yes. Right, I'm trying to work out about thumb, aren't I? So one of these is the thumb tables. I can never remember which one it is. DARM tubble. This one is that's ARM v7. Table 2 is the thumb instructions. Okay. So this is interesting because it's got brace S on listed on these ones, but the S isn't turning up. If I compare between these two tables, interesting. S. So there is an S variable, S variable, S variable. So I think what it's thinking is this S variable here is off there. If I go back to the instructions here, let's see, what's that? That one was not setting flags. that instruction. It can update based on the value. Or there's this version, which always sets the flag, so that depending on which encoding it's using. That's kind of interesting. Oh, I'm going to have to work through this. Nemo wrote a small RISC OS desktop app that installs a keyboard cat meme on the icon bar. And every time you press a key, the cat starts typing. That is actually kind of cute. I really like that. Yeah. Right. I'm trying to work out what I'm doing for this. So the important bit here is the instructions for 000. It's the LSL. Somewhere down here. There should be a MOV instruction. It's a MOV. Hang on, that looks way too long. That looks like too many bits there. Yeah, there's way too many bits in that. And that's also not got the right values on it. Maybe that's a thumb2 instruction, I'm not sure. Oh, there's his. Oh, that's MOV. Oh. Have I mentioned how much I hate reading these things? See, here's the one that we should be looking at, but it's been commented out. Probably because it's actually just part of the LSL pattern. This one here, it matches this one, but it has a immediate value of 0. Which means it's probably fixed up in the code itself. So if we have a look in the code, thumb here, and we look for LSL, thumb shift immediate. If the shift is 0 and it's an L instruction, it's actually a MOV instruction. Change it to a MOV. It's actually a MOV instruction, but it's a MOV instruction with an S on it. MOV. That's the only place that they're defined. Because these then come through a table that's over here. It actually says what the different encoding types is, if I remember rightly. The different labels that you're using come out here. Oh, I hate these. Where was the actual instruction names? The MOV in quotes. MOV in quotes. No. And it's not in here, I know that. I don't think it was in this one. No. No. Would it be in a header file maybe? It wouldn't be in a header file, that would be weird. Where do you get encoded? Come on, surely. Surely I should be. Oh, maybe it's in here. Ah, it's in here. Here's the mnemonics. So there's a mnemonic for MOV. Is there a mnemonic for MOV-S? No, there's not. Okay. So if I look in here for iMOV, no, it doesn't happen there either. I am going to try changing this and see what happens. So the easiest way for me to change this is to also have a disassembly of a thumb instruction and then print it out. So here we go. So we do DARM, I think it's thumb disassembly there, and then we can find out what the instruction was. So if I jump back to this one, we're looking for this mov instruction. Oh, it's 0. Oh, I should have known. Sorry, I've missed a whole bunch of the chatter here. See you, Ryan. Yeah, not a lot going on there. A lot of chatter, but that's fine. Right, okay, let's try this second instruction. I think that's darn thumb is how I meant to do it. Let's have a look. Darn thumb disassembler, there we go. That's how you do that. And I think should be an S bit in here. Yeah, that one there. Does this instruction update the condition flags S bit? So if I go and do that in DARM RISC OS ammo makefile lib export, and then RISC OS ammo makefile example. Build that and see whether that works. Oh, lots of building. Lots and lots of building. And there's the example built. I'll try dev common command af32 dot, what was the example called? DARM. Very slow. Right, so it's given me a mov R0R0, which is what it was giving me in the main code. So if I go and tweak the code now, so that in thumb, oh, I've lost the line, I didn't double click on it. The bit that did the imov, here we go, imov. I think that D to S equals 1, because in here we can see that it says explicitly set the flags equals true. So what I can do is give a reference to this. This encoding always sets the S flag. Okay, and then we try building that. Yeah. Linked, and then we'll run it. Mobs, exactly what I wanted. Brilliant. Okay, so that's going to work with the mobs, but what about the other instructions? What about the other ones that we were seeing here, like EOR and OR? So let's just grab these grab one of these, EOR. And put it into the example code down here. I could probably make this into a table-driven thing in the future, but right now this is just easy enough to copy and paste. Okay, there we are. Build that one. Oh no, wrong. Oh yeah, here we are. That's what I want to be. Export it and build it. No, I need to run it, don't I? Sorry, forgetting what I'm doing. Run it. EOR, right, okay. So what I'm going to do is I'm going to make it actually do all of these things. Arctic has asked whether I could recommend a microcontroller better than the Pico that could run MicroPython without an OS. I'm sorry, I don't know a whole lot about microcontrollers, I'm afraid. I know these days that that they're a heck of a lot more powerful than they were back in my day. I've really only worked with like quite high level systems. A lot of the Cortex M's are pretty neat, obviously, but it depends on what sort of things what you want for better, really. I mean, these days you might be looking at something like the Raspberry Pis for a lot of things anyway, because, well, why not? It does all the things you need a lot of the time. But I genuinely don't know, I'm afraid, Arctic. Right, let's find instruction EOR. General purpose instruction. Let me just check that the split on this is. I think that's actually correct. If I have a look, so if we have a look at this up here, it's pulling it out of thumb instruction types using the top 8 bits as the reference point for that. So if we have a look at the instruction types, which are in thumb table here, and we look for GPIs, GPI is that one, that one. There's quite a few of them then. But only these ones, not even those ones, I think. If I find the exclusive OR, come on, where's exclusive OR gone? Exclusive OR immediate. Your setting. That's exclusive OR immediate does have an S flag. If S is 1. And then for register, that appears to be a constant. Set flags equals whether or not it's in an IT block. Ooh. That's kind of fun. And then the special magic encodings for this. That's quite clever. Yeah. Ooh. Ah, right, that's a thumb 2 encoding. Fair enough. So EOR doesn't necessarily mean that it's going to be that, does it? Instruction types, GPI. So this one here is, yeah, almost certainly lining up with that pattern, isn't it? Yeah, I think so. What's the other ones? Your and things. Add with carry. Immediate. That's got an S flag, but ADC doesn't. That's the register forms don't. It's the register forms that don't have an S variant, it looks like. Come down here, look at this, we've got and your LSL, OSR, that's 00, ESR. And there's only 2 no, that's saying there's only 2 registers, whereas here we've got 3 registers. Not sure. Yeah, that's IEOR. Is there another place where it does EORs? No. Six and taking 3 bits. That's not that form. It can't be that form either. Oh, I'm on add. Oh, I don't want to be on add. I want to be on and 6. So yeah, there's 6 bits. It's got things in there. That class of instruction, but this type instruction is type general purpose instruction. Oh, sniffling. This is where I end up being confused. Oh, I should probably be using bset rather than 1 for this. Looks like. Yeah. I'm pretty sure this is not going to be the same for all of the encoding types. That's the thing. Where was my table? Where was my table? It was in Gen 2, wasn't it? The second Python file, which I can't find now. There we go. Right, and I was looking at the encoding for an AND. I'll go back for an AND here. Was it an AND I was looking at? Yeah, AND there, which goes into GPI lookups. Yeah, so that's a long thumb 2 instruction. This one is the one for just register to register, and this one is register to immediate. How are those different? Because that's got a long pattern there, and it's got a short pattern, and feel very dim sometimes. Dave's sending me random pictures. Well, not me. People that I'm chatting to. This one here, zeros there. Why? There is only one encoding for T1. Oh no, there's the immediate encoding here. Sorry, I apologise. Yes, there's the immediate encoding that's using that big thing there, big value there, and with the I in it, which is what we were seeing in here. Oops, no, wrong window. This ought to be over here. And switch to this. So all of these don't have an immediate on them. Oh, right. So the GPIs are the ones that don't have an immediate 8. I'm guessing, I'm hoping. Probably. I mean, I can check this. So that's a mobs, that's an EOR. And I could probably check whether what we get if I do it the other way around. So if I go and do, I get a different instruction encoding here. Let me find the immediate instruction. Not immediate. What's the immediate? It's only in thumb. ESR with an immediate, and then ESR without. Okay, let's just compile that and see whether that does hit this particular case. Because if it doesn't hit this particular case, then it's irrelevant. Okay, build it and test. So that does come out as an EOS. And presumably all of these other ones will come out the same as well, which is, I think, what we want. Where's EOS? I've lost it, but I want to include a reference to it. EOR, here we are. Copy that. Oops. These always have the S-bit set in encoding. Mnemonic. There we go. So, having built that and exported it, I should be able to use it. I can also export as 64-bit as well, so I don't forget that I've got that code in there as well. Okay, you doing that? You're doing that. Okay, fine. Let's get on with it. Now I can go and build this. From cd .. Yeah, there's my command that I was using to build it. So I pulled the binary into the right place. That's good. Now, having done that, I can run my RISC OS 5 debugger, classic debugger, my debugger. I can print this out. So we're getting the mobs in here now. Mobs, EOS. Okay, so the other ones aren't. That's interesting. Ow, my eyebrow's sore. Right, let's write that to thumb, and then we'll do the comparison and see what we should be seeing. Because I think this is going to be quite similar. or getting more similar anyway. Also, if I copy the test data slash no, expect debugger thumb that one to be from Pyro, so I can compare those as well. If we compare classic against my output, oh yeah, that's not very useful because we know that this is outputting something that looks wrong anyway. Maybe I'll compare against Pyro instead. That might be more useful because that's using the standard form from Capstone, and I'm really confident that that's correct. Yeah, so when we come down to these, we've got the EOR setting flags. Interesting, so the Pyro version doesn't use the triple unified form, but we do. Fair enough. It's just slightly different forms of them. And so adds subs should have had it. This one here should not. Interesting. Interesting. Okay. Let's have a look at what we can do about ORs first, shall we? Because maybe that's an easy one for us to do. So here we've got the OR. Ooh, fall through to MVN as it's almost exactly the same except for passing it RN. Okay. OR and BIC. Let's have a look at the OR and BIC instructions and see what variants we've got of those. OR by register, ORS. What do we do here? We're doing ORS for a register. So yeah, it looks like the same thing. Fine. Does MVN also have the same pattern? It does. Here it's using the set flags, but the definition is for setting flags. So that's quite nice, which means that we can put the setting here. Easiest way to do this, just copy the bit we had up here. And probably want to actually include the example code in my program, don't I? The example program. So that's the one there. Back into DOM and look at example. Here, please, yeah. Oh, right, it's time to start thinking about this in a form as a as something that you should be expecting. So let's try and do a table. Oh, table for the thumbs. Okay. uint 16 t. Actually, I want it to be a struct, don't I? I want to actually have. Oh, I'll just output this way. I don't care. I'll just do them this way. So OX 1 2 3 4. Yeah, Rust and Zig I would like to learn, but Rust is. I worked for a place very briefly that used Rust for all of their things, working with RISC 5, and that looked really interesting. It also, with the extensions for tagged memory addresses, you can do a whole lot of additional protections and stuff. Odin, I've not come across that one. I don't know about that. That might be quite an interesting one to have a look at. Zig looked incredibly powerful, but also a little bit magical in how it was trying to do things. I mean, maybe that's just me not understanding how it was doing things, but whoops. size all. There we go. And then it'd be nice if it actually included the instructions we were expecting, but right now this is just fine. Inst uint 16t inst equals inst bracket I. Probably should work, don't know. Probably missed something. That was not what I wanted. Excellent. Right, so now we've got the ORS with a S on the end of it, which is nice. That is what we wanted. If I go back to the thumb code, so OR and MVN all doing the same thing. Mol. I was trying to have a look at the differences, wasn't I? So look at the differences and go adds and then subs should also have them, but only for certain variants of adds and subs. It looks like. Okay, so we'll have a look at that. I add has an immediate 8. Okay, so we need to have a look at this and see. Add register. Which ones were the ones that were? So it's adds with a const with an immediate was the one that had an S on it. So it's an immediate here. Again, that's always using a S. In fact, both forms are always using S. Interesting. Okay. Dum, dum. Destination. Oh, that's the along the thumb 2 encoding. So I think this is also S equals sorry, D to S equals B set. We'll give a reference again. Okay, let's try that. Oh, I need to find an instruction that does that, don't I? Let's find an instruction that does that. So this one here does, and then this one here, I've got to ensure that it doesn't. So let's also add both of those to the table. Oh, you know what I can do? Well, 0. This one is, that was the EOR, wasn't it? Mobs, sorry. The important bit was it was mobs. This one is, yeah, that's right. EORs are for R7. And this one is ORs R7, R3. And this one is the magic one that we were having issues with. That is add R7, R7, 42, so that's a constant add. Go back to here. And then there was the other add that I wanted to make note of, which was, oh, and the sub as well. Let's do all these, in fact. Let's copy the lot. That's a good idea. Let's copy all of those, all the way down to here, in fact. Why not? Oh, God, I pressed the wrong button. Copy all those, and then we can just insert them directly, can't we? Oh, it's already there. Doesn't matter. OX, comma. Now, oops. We know that some of these should be coming out. Let's go that with S's on them, because we know when we look at the comparison here that it's only the R5 SP and the R11 R3 that we don't. So all the others of these, S, 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 S. The RSP was an S, wasn't it? Yes, the RSP had an S. Good. So, those are the ones we should be getting. No, wrong window. This one here. Fortunately, at my new place, I'm going to be learning, working with Python, so I know Python pretty well, thankfully. Here we are. Right, so although I have changed that adds, it hasn't changed this add or this add, so that's correct. Which also means that these subs haven't been changed, which needs tweaking. See what we can do about that. So let's. But it says here that I've changed that one with sub, but it hasn't changed it. iSub. Let's have a quick look and see if there's another one. SP immediate. That won't be. That's the one that isn't setting the flags. I thought that should have worked. I thought that should have set the bits. Confused there. Is that, hang on, is that a thumb2 encoding? Is that why it's not a longer encoding? Is that why it's coming out differently? Not that thumb table. I want to look at the Python file, don't I? This one here. So I'm looking for the sub encoding. So here we go. Sub-encoding that has two registers, R5, R1, R3. Three registers. Also, I should look it up on here as well. Sub register. No, the three register form is the only form. M and G. An S should be set. And I thought that's what I'd done. Because this is case sub. But it doesn't have an immediate 8. Ah. Does that mean that it's a... Hang on, what's the encoding here? 0001101. That's a interesting block of registers. Block of bits, rather. And that would be 1 plus 2 makes 3. Skip 4, add 8, and add 16. Hang on, I can't do the maths on that. That's too hard. I'm too dumb today. 110110. There we go. 26. So 26 and 27 is what I'm looking at here. 26 and 27. Okay. So I go into this table here. 1, 2, 3. Oh, it's in threes. Some of them are in threes. Some are in four. Automatic generate code that's not quite as easy to read. Thumb 3 reg, I think, because that's what it looks like. 3, 4, 5, 6, 7, 8. 8 times 3 is 24. Yeah, so I think that's right. I think that is correct. So thumb 3 reg. 3 reg is the bit I need to look for. And if that's one of the encodings, what would be the other encoding? It would be the one that's before that. So is that an RSB maybe? RSB is in fact that's a 2-byte encoding, a 2-word encoding. Immediate one now. How do I find out what the other encoding would be? I go and have a look at the table, don't I? Not that table, the other table, this table. Because I'm looking for the same encoding as this, not that one, as this one here, but with the 0 value there. So I want all of those, copy, find that 0. As. Oh, okay. So both of those are, yeah, add and sub. Keep as equals reset. Give it a reference to. Oops, no, not that. Not that. Go back, thank you. No, go back then. No. Sub, there we are. All right, so those should be correct now. Fingers crossed. So the next one is the sub with a immediate value, which is another encoding. So sub immediate, which is down here in this sub immediate, and that is a forced set because its set flags is based on the IT and it always uses the label. So I sub. Is that not the same as this immediate 8 one? Right, back to my table again. Look for sub bracket S. And the sequence we're looking for is 0001111. Is it not that one? Oops, that's too many highlights. Hang on. Is it? Oh, there's some up here. I forgot that one. 0, 0, 0. There we are. Immediate and 2 registers. And that value is that's going to be 30 and 31. 30 and 31, if I go into this table, will be down here somewhere. Not the MOV SP. Is that general purpose instruction? Can't be. That was 26. 26 was here, wasn't it? 26, 27, 28, 29, 30, 31, 32. 8 times 4. 8 times 4 is 32. That's too far. So this is in thumb is immediate 8. This is in the chunk thumb is immediate has immediate 8. Has immediate 8, which is this chunk, which should have gone to here. I thought. And so I thought it would have ended up with the one set. There's no other places where isub is listed. There's no isubs in here. Oh, instruction label. Oh, there's some down here. That's definitely done. I said that was 30, didn't I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 20, 30. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, this would be 9. 0, yeah, that's 9. This is 19. This is 29. 30, 31. So these two here are the ones I'm interested in. Let's look at the instruction types. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 18. 19, 20, 21, 22, 23, 24, 25, 25, 26, 27, 28, 29, 30, 31, 32. So it should be these two. Has im8, which is the one that I gave it, has im8, which is here. And then if the instruction was an isub, make it do that. And mark it as set. Just going to put some debug in there and see what happens, because I'm confused about that. I thought that code should have already been tweaked. it only went in for the add-s. It didn't go in for the isub. Huh. You know what? We can just print it out. I don't know where you guys are, but it's quite warm today. Seems like every Sunday comes out with it being quite warm, which is nice, but still quite warm. Build that and run it, and then yeah, that's going to tell me what the instruction type is. Because clearly I'm getting something that I'm not expecting there. There's an odd encoding that I'm not sure about. Okay. The adds is encoding type 36. The subs here encoding type 39. This subs encoding type 40. So you know this subs is 39. This sub here is type 40. Okay, so I've got to find instruction type 40. 40? That's a okay. That's not the sequence I was expecting. Let me go back to there. 1 0 1 0 0 1 0 1 0 0. No, not that one. Not that one. And that's not an encoding. That's not an encoding number. Yes, it is. Hang on. So I want 2 zeros. So 0 0 0 comma 0 comma 1 0 1. That's what I should be looking for. I'm confused. I'm quite confused by that, because that's 1 2 3 4 5 6 7. That's the right number of 1 2 3 4 5 there. Okay, let's just take some off there. Let's take off that and see if we get a match. No, that's 2 in the wrong place. That's in the wrong place. In the wrong place. In the wrong place. Okay, so take off another digit. Wrong place, wrong place. That's a comparison. Well, a comparison is a sub that's setting the flags and throwing the result away. Maybe I should have put a quote at the beginning of that, like that, so I'll find it. It's just a comparison. Comparison instruction over here. Come, immediate. 00101. Isn't it? And what is the encoding value for this that we're looking at? 1E. So OX1E is the top section, so I do binary of that. That's a very different sequence. This instruction should be 111110. If I've read that right. Yeah, 1110. Which is 30. But it's saying that's coming out as 40. Have I printed out the wrong number? Have I printed out the wrong number? Am I looking at completely the wrong thing? I'm looking at the wrong thing. I'm printing out the instruction type, not the... Oh, dear me. Right. Let's try this again. If that's the instruction type, then I'm pulling out something that is different to what I was expecting, and therein, double H, here we are. Encoding types. Yeah, here we go. So this is all the ones that are there. I don't know what if this actually is coming out as. So, oh dear, I feel very silly now. What I care about is that should write 8, which is then coming out of that. So, but the number we're actually trying to get to is 30. So if I look in the table here for number 30, not this table, no. Not that table. Where's the dumb table gone? I didn't open it, that's why. So types, 30 is what I want. And I looked at this, didn't I? And I think it came out as immediate 8. Has immediate 8, I think. I can confirm that. Let me print out what the value of has immediate 8 is. Again, really want a debugger. Whoops. Just closing the window to try and keep the noise down a bit. People outside working, which is good. Like people working. I'm rarely working. And im8 equals this. So this is what the value of the one that we're actually thinking we have. Oh. Linked and 36 is what we're thinking we have, and it's not 36, it's coming out as 40. Instruction types, W shift plus 8 equals I've got to be doing something dim here because that does not look right. Shifted right age is 30, which is the number I was expecting it to be. 40 is the type, I should print out as type equals, just to make it clear what I'm doing. And it's saying that the type is some big number. 40 in fact. And if thumb im8, now if I go to here, no, not here, the header file, sorry. So if that's 36, this is 37, 38, 39, oh, 40, add and sub. Huh, okay. So, Yeah, that meant I was doing it in the wrong place. Thumb to reg im. Thumb to reg im. And d to s equals b set. Oh, not the same link to that. This is the sub-immediate. Now try that. Oh, no, badness, badness. $240. Oh, S to, oh no, that's bad. D. Hopefully, if I get this chunk of things finished, I can go and have another drink, and then we can a break, and we can come back and do some more. I'm sure this all made sense when the author wrote it, and it does make a lot of sense. It's just it's a little bit harder to work out how to get through things. Right, so the only one we're missing now is our RSB here, which is an encoding of 4253. Okay. So have a look in here for RSB, and it's a register immediate. So looks like it's probably this one. Yeah, there we go. Register immediate of 0. That's quite interesting. Yeah, it forces the constant to be 0. I guess that is what you do most of the time with RSB. Well, that's the same as negate. That's the same as negative, not the same as negate. Yeah, anyway. We can get rid of some of this debug. Oops. Oh, too many. I'll leave that debugging because that was quite handy. This one's not. And we were looking for RSB. General purpose instruction with an immediate value of 0. Yeah. This link here. D to S equals 1. Come on. Yep, that's doing the right thing. Okay, so remove the debug from there. Oh, printf, sorry. This debug can go. And then that should give us the right answers here. Right, that's looking better, looking much better. So, rather than just committing it, let's go and check it in here, in our code. So we want to build, copy, there we go, build the code. Just shut that window again. And then test it, which was this one. Putting T in there better. Right. Oh, I think I'm feeling a bit better about this now. Oh, it's all very complicated trying to make sure all this code works, but I think we're getting there. I think we are. Right. So all of these instructions are now coming out with the S's on them, which is what we wanted. And if we do a comparison there, hang on, pick this up and put it here, reload the new content. Yeah, so the differences here are it's still printing out in three register form in the version we're using. That's not a terrible thing. I can cope with that. This one's coming out okay. That's the right values. ADR 11, yeah, it's fine. Mov. That one, mov of a constant, is coming out as a non-mov. That's interesting. So that's probably one we can fix. Yeah, let's just do that one. But I think that's probably the last of those main ones that we need to care on. Probably, anyway. Let's put it into the example. Right, there is, what was the instruction? It should be, sorry, I've just copied it off the screen from you, but that's okay, that one there. Right, that's what that should be. And I think it's coming out as a plain one, so not plain mov. So I'll just check that, and which should be the same thing. Times like this I do think, well, why didn't I write it myself and actually use the tables to make the instructions come out right? And maybe I should have done, but I'd rather reuse somebody else's code and let them have done the work and mostly get it right. It's just a lot easier. Thumb has immediate 8. I think this is the one we want to use. Yeah, d to s equals reset. And this will be the mov immediate. Yeah, I think that's the one. I've lost it. I've lost where I was. Yeah, that's where I was, isn't it? Okay, rebuild that and we should be good. I think. I'm hoping. I know I've said that a lot. And magic? No. I really should tweak this. Yeah, there we go. Little mobs in the right place. Cool. All right. So that should now link and give me the right code as well here. Output to there. And then show me the differences, please. Yep, that didn't work. I'll pick it up. Reload file, yes. Mobs, yep, so the difference now is just that the value is slightly different formed. So that's cool. Right, so no, wrong one. I want to be over here in DARM. Git commit minus A. Let's just check. Yeah, so we've got a table in there that generates things. We've got this set of comments in here, no printfs. Yeah, that's all good. Improve thumb mnemonics to include implicit S-bit. Thumb instructions often have an implicit S set bit, or an S bit which is dependent on the status of IT. IT is the if-then construct that allows you to do different instructions. It's kind of like the condition codes that we had on the original ARM instruction set, but munged into thumb instructions so that they don't take up as much space. Basically, you make them into two instructions. One that is set up the conditions and then execute them. Or an S bit, it depends on the section. But the mnemonic always uses the S bit. Okay, that's now done. We can push that. That will then go on to its build and test and things, and then we can do this and make sure that this is all working as well. Yeah, there's actually no code changes in here, is it? It's only these bits. So the bit that's different after this is the memory I thumb code. So I believe we have a test for this that we can just invoke, and I think we just want to accept the changes because I don't think there's any differences now. I think we're looking at a good set of changes. Well, I say that, but I'm just looking at the differences down here, and many of these are just normal. The differences are in just numbers and comments and the like. But this one is coming out as an undefined instruction, and it's the IT flag, which is if then else, which I can't find in the instructions here. I'll find the IT. Here you go. Yeah, which gives you the actual encoding for it. In fact, it's not coming up right. Might be an issue. Might have to have a look at this one. Yeah. Anyway, ooh, excuse me. It's all quite exciting as how the if then else works. Oh right, yeah, I get you. Yeah, it tells you which ones you want to be executing. That's fun. I'm going to leave it as that. So we have a look at this. We've got oh, that is actually different. One is saying stumia exclamation mark, and the other one's saying stumia without the exclamation mark. That is a functionally different instruction meaning, and so I can't just commit that. Oh, I thought it was done. Right, what I am going to do though is take a short break and grab myself some more drink, and then we'll come back and we'll fix that one. So I won't go and commit things as they are. Well, I've committed the changes in DARM. But I'm not going to commit this change file just yet, because that is a functionally different instruction. Okay, so I'm going to come back in about 10 minutes. Back at about 10 minutes. I'll be 15:05. Might be a little later, but we'll see. Okay, so see you in a bit. Bye. Hello and welcome back. I hope everybody really enjoyed the test of the emergency alert system. Ooh, I'm sitting in the dark here. It really got that dull. Gosh. Yeah, I'm just sitting in the dark. Give me a second, I'm just going to put the light on. How's this one do? Is that better? No, that makes very little difference. Try this instead. That's a bit better. Yes, we're not too badly off with that. Yes, as I say, we managed to miss the test of the emergency alert system, which was surprising to me because I'd completely forgotten about it. I was in the middle of making a cup of tea and it made me jump and shake my hand whilst I was pouring water. Not the end of the world. Although, strictly, if that alert goes off, it might be. So, yeah. Okay. Yes, there was this exclamation mark that we're missing here. So, should be putting the exclamation mark on there, isn't. So, let's have a see. If we look over here at Stumia. Exclamation mark writeback is implicit on this form of the instruction. The W form is not, it's not implicit. Okay, so yeah, I think we can do that, yes. Yeah, talking about the end of the world and taking a cup of tea is rather British, yes. Yeah, making a cup of tea whilst the end of the world's coming, yeah, it's fine. If you ever get an opportunity and you see that Threads is on, or you have a chance to watch it, don't, because it's terrifying. But it's a good end of the world film, documentary. Yeah, Threads. Definitely not something you should watch when you're like 8 years old, I think I was when I saw it. Right, anyway. Enough talk of Armageddon. Let's see what whether I can get an exclamation mark to appear in this text. Gosh, it seems rather pointless when you put it like that, doesn't it? Coding brings on existential crises. Problems. Stumia. Yes, the writeback is implicit on that encoding. So we need to find out where Stumia is. Do we actually have a Stumia STM? Oh, no, there's none of those in there. Interesting. But it is this pattern here, 1100. So we can have a look in the table. Quote, comma, 1, 1, 0, 0. Looks like they might be finished outside. I might be able to open the window again because it's rather warm in here. That looks 1100. Yes, that's correct. Yeah, so it's that one there. That's right. So it'll be a different type of instruction because it'll have a register list in it. I wonder if the LDMIA has the same thing. LDMIA. Ah, right. It's 1100 with a 1 in it. So that pattern there plus the 1 is the thing it's using, and then it's got a register list. So thinking back to how things have been done in the past in here, I expect there will be a list constant in it. Oh, that's helpful. Reg list. It's not a push or a pop because it's using a different register. Well, reg list will be the thing that's used. So let's have a look at reg list. Read write register. To do writeback support for LDM. That's kind of interesting. Thumb read write to memory, read write register. Register is there. But I mean, literally all it is oh right, for LDM, writeback is whether the register that we're operating on is in the list. So presumably it's going to be W, isn't it? W equals, sorry, let's do this. If the instruction is going to be that, oh, not that. If D to instra is LDM? If it's an LDM, because it only applies to LDM, and we can comment that out. Give the reference, copy the reference, paste it there. If D to RN, one shifted left, that bit, and the reg list equals 0, then it's writeback, which seems to be pretty good there. Just give me a second, put my phone in my pocket. There we go, yeah. But for the STM instruction, it'll be the other way around. Will it be the other way around? Actually, the STM instruction, I'm not sure. Let's see what it says. I thought it said it was always present. Writeback is always true. So, in which case, writeback is always true. There we go. Oops, went a bit far. Ooh, everything's gone slow. What's going on? Let's make sure I quit some things. Screen sharing. Give me a moment. Interesting. Quite interesting. Should be just fine. Not going to worry. There we are. And then this one, as I say, it's the writeback on this is entirely true. Always true, rather. So that should address the stummier issue. C124. OX C124, and then I'll paste the what it should be. It should be this. There we are. Nice and easy. Excellent. And if we don't get the exclamation point, then we know that it's doing it wrong. Back to DARM, rebuild and test. Rebuild and test. Oh, and open the window because it's roasting. All the work seems. Oh no, I got it wrong. Well, what do we do here? 295 in there. Oh, the one that it was telling me I'd got wrong. Yeah, I put too many brackets in, didn't I? There we are. Dum, dum, dum. STM Oh, we just didn't write it out as STM, not STMIA. Is that? Hang on, I've already forgotten what it was looking like here. Oh, does that mean I've already tweaked it, haven't I? That's right. I've already tweaked it to output the right thing. But that's now doing the right thing. So go back to here. Yeah, we've got writeback support. Next one is add writeback support for LDM STM in thumb. And the thumb instructions are decoded. The STM has an implicit back equals true, and the LDM has an implicit wback equals true so long as the source register is not in the register list. Okay, then we go back over here and we build this. Build, thank you. There we are. And then we run it. Yeah, that one there. Whew. Not doing too badly. It's taken a while to get just these few things working, which is quite frustrating, but it's not the end of the... I think I've said that already. Yeah, there we go. We've got the exclamation mark coming up now. Good. That's much... I feel much better about that. Yeah. All right. So, yeah, that was pushed, wasn't it? Yeah. So now I just need to make this get updated. So, mov, copy. Where was it? Make. That's the one. Make the tests. And these should come out okay. I also realised, sorry, it was a very loud crack then. I also realised that I could actually do more in some of these tests. So rather than just testing one memory I command, I could test like 3 or 4 of various variants, and then it would be more efficient because I wouldn't be sending it to the server, waiting 5 seconds, getting the result back, and then whatever. It seems to take way longer than I would like on this, and I think a lot of that's the Pyromaniac startup, but I really would need to do a bit more testing to work out what the bottleneck is there. And I'm the only person who uses a lot of this, so it's not such a big deal. In theory, Pyromaniac on the server could sit as a service, ready running, and then have them all in hand so that they can be used immediately. But I haven't got around to doing that. Lots of OKs. Well, 1, 2, 3, 4 OKs. And then this one, which is almost, yeah, there. We're good with this now, aren't we? All the ones that have got S's on them, I've got S's on them. These ones have just come out with slightly different. Ooh, well, that's different there. That LDR instruction has come out with a different address. That was subtle. These ones are coming out okay. This one's coming wrong. Well, that's interesting. It's interesting, but is it actually interesting enough that what does the RISC OS 5 debugger do? Because it's possible that one of these is wrong. Well, obviously it's possible one of them is wrong. We compare us against RISC OS 5. Yeah, there we go. That's that LDR instruction. So RISC OS 5 says it's going to 34, and we say we're going to 36. Interesting. So we're out by 4 on that. Interesting. Okay, so is that in my code or is it in DARM code? Let's have a look at Rodis. Do we have any special handling for LDR? We do. Oh, that doesn't look right. Or is it right? That's an for the ADRA and for the LDR. So let's have a look at the LDR and have a see what it says in here. So LDR of a literal is what we're trying to do. Yeah, because it's LDR of a literal of a label. That's right. Operation is the base is the aligned PC to 4 and then add it on. How interesting. How interesting. And when we do an LDRB, it's also aligned to 4. Ah. So it just happens that that was ending on a +2, and so it ended up being different. So that means that we need to do, yeah. Actually, it's only applying to this LDR. Let's just apply it to this to begin with. I'm going to leave a note actually to reference this because, yeah. A word for both LDR and LDRB. And if I'm citing that, I should probably put both of the links on there. LDR literal. There we go. LDR and LDRB. So uint 32 rounded equals address and not 3. Subtle. Whilst I'm thinking about that, what about ADRA? And ADR, there we go. Oop, that was the window slamming. If add, then align and add. Otherwise, align and then take away. So same thing over here. Interesting. Okay. Address align is always PC rounded down. Sound down. Copy and paste. And over here we'll just stick in the rounded. Right. And we can try that one again. I want to build first. There, yeah. Now run it. Let's run the test itself and check that it's working rather than throwing it at the server. Oh, come on. What was it? It was the LDR, wasn't it? Yeah, LDR there should be at 34. That's correct. So if I now look here, yeah, we've got address number 34 now coming out correctly. That's much better. Cool. All right. Phew. It's quite fun, but it's quite tedious, this stuff, I think. But no matter. Right. So there was a fix on that, which is nice. Let's run the. Actually, let's move this one down. So the one that's doing the thumb code, we're almost exactly right now. So it should only be that instruction that's different. Oh, did I copy across the hello world code to do dump I? I don't think I did. I'll do that in a few minutes. Yeah, let's get this one sorted first. Make tests there. Come on. I mean, it's not like there's a huge amount that we're doing here, but excellent. That was failing on just that one. It's now different in the right way, so that's good. Let's move that to the right place. And we're good. So what have we done here? We fixed the, what do we fix? Not sure what we fixed actually, come to think of it. We fixed the LDR, STR, and ADR for that matter, loads, instructions using unaligned addresses. The LDR, STR, ADR instructions always round to the word for PC rather than using it explicitly. Okay. The DARM library has been updated to have the S flags on many of the instructions rather than just a, I think full stop, that'll do. Okay. Okay. So that's completed that thing, and we now also need to just do this star dump I, because I just have a look at this. I think it tells us that we're missing a file. Yeah, we're missing hello world. So have a look in here. Test code. Yes. We don't have hello world. Let's just copy it from projects RO Pyromaniac /test code /s/hello world into s/hello world. Yeah. And then build it. You good? Cool. Now we should be able to just run that one test. Dump I. And see that it comes out the same or close enough. Ooh, lots of different. Ooh, bin hello world not found. I thought I just built it. I thought I just built it. Oh, it's hello world. Yeah, hello world FFC, which should be executed as. Oh, when I send them to the server, I've got to say explicitly which things I want to send. And where do I say that? Is that in the make file? No, not in the make file. Is it in run on build server then? Run on build service. That one there. Yeah. bin / hello world. Ooh, world, not hello world. There we are. I probably want to add the file as well. So add s/hello world and bin / hello world. Do the test. Right. What are our differences then? So, yeah, we're not decoding the memory addresses out. That's not a huge thing at the moment. We could do that, but we're not. This one, fun instruction, says it's undefined. Not going to worry. So I guess, just prints out X user on ours. That's not very useful because if I don't know what the number is, I can't see it. So I might want to change that. Not like now, but in the future. And then we've got this raw thing. So raw and LSR, we can fix that up later. I think that's probably a relatively easy one. And then we've got a lot of differences here. Yeah, constant values being different, it looks like, and slight difference in naming. We call them CR and it calls it C in Capstan. That's the raws, that's the case of that. There's also a slight difference here for higher same or carry set. Not a big deal. I'd like to fix this SWI thing so we actually return a number instead. I don't like us using X user because that's not helpful. So, is that in Rodis? I think it's in Rodis, where we look up the SWIs. SWI name, look up SWI. I'll bet that's in introspection. Oh no, it's here, number to string. If we don't have an error, if we have an error, then return null. Otherwise, return the buffer. And if we do have an error, let's return null. What do we print? We just leave the value the same. Oh, come on. What does... Here we go. What does the PRM say? So find, what was it? Oh, I've lost the thing already. SWI numbered string. There we go. Find that. Searching. Not that one, not that one. How about this one? Actually, I can probably follow the link, can't I? Go to page 6. There we are. If no name is found in the modules, the string user is returned. And apparently I'm putting an X on the front of it for my version. Okay, well we can handle this. Okay, so if buffer bracket result equals buffer, if result is X, result plus. If result u, u, and result bracket 1, X. Ooh, I'm missing my letters here, aren't I? E. Return null, in which case we'll return back the failure, and it will just should just use the code for the whatever it's called, SWI itself. There we go, there's a build command. Oh. And I should actually just disassemble hello world. Where's the command gone? Here we go. So if I change this to be dump I hello install world. Oops, that's not what I wanted. Oh, so not typing the right things here. Oh, bin.hello world, isn't it? There we go. La la la. Some of this is quick, some of this is so slow. Right. So now we've still got we've got hash ampersand. So I'd like to get rid of that. Maybe we could do it in here actually. We could actually make it get just converted here. Sprintf to buffer ampersand percent. Oops, no, that's not ampersand. Ampersand percent X, because we'd like them to be capitals. And then SWI num. There we go. Build that and then try it again, and we'll see where we got with a hash from that, which I think we should have done. Better, yeah, we've got SWI numbers coming out that are closer to what we were seeing before. So now we should be able to run the dumpy test and have a slightly closer version. So SWI numbers coming out there. Number there, number there. Those are good. Maybe still at these differences for the RORs and the like, but I'm not feeling bad about that. Commit -a. Let's just do an update the, what's it called? SWI instruction to use X numbers when unknown. Instead of using X user or X user when the SWI name is not known, we now use just the hex value. Okay. And also add the hello world binary and to test works. And now we'll just have a fix of, which one was I going to fix? What was I going to do? I've forgotten already. Oh, I was going to see if I could quickly fix this ROR LSR thing as well, because it's generating an irritating number of differences. And otherwise, I think these lines are exactly the same. There's only certain ones that can have these present on it. If we could identify those, then we could save ourselves a bit of time. Let's see. Here, that seems like good. No, I'm not changing the mnemonic, I'm changing the instruction, aren't I? It's not one of those instructions, definitely. Change the ROR LSR ROL ASR. Capital. Yeah, I think we can do that. So if we capitalize the mnemonic by now, I think we haven't. We haven't capitalized it yet, so all of the comparisons are going to be lowercase. So what instructions can we use? Can we do this on? So it's going to be a mov. Didn't I have a magic thing to compare lots of? There we go, mnemonic match. There we go. I use that to do it. Oh, in fact, that's exactly them. That's the conditions I want. So let's get rid of this tat up here. This is clearly not where I should be doing it. Go back to this one because this is the only cases that it'll be. All of these are allowed to have those on them. So, code immediate. I guess there's immediate constant out. If we have any. Although it doesn't apply to this particular hash thing here because it can happen on all of them. So I want those if this can be a separate condition. Boom, boom. I think also MVN should also be in this list. I have a feeling it should be in that list up there. For now, not going to worry. If something or other, what am I doing? Oh, I've deleted the thing that said what all the things I was trying to do. Fix up the ROR, ROL, LSL, LSR, ASR. There we go. Inside, what's it called? ARGS, isn't it? If shift bracket 1, 2 4. Oh no. The point is I want to find them in lowercase. This is the matching case. It is shift bracket 0 bracket equals clear and equals not 32. Clear that bit. That'll make them all capitalized. So that's RO done. LS. Ooh, actually it's the same check for that, isn't it? So if not shift and we don't have to do it again. Oops. We have to repeat the code. And then we'll find, so I'll do RO something LNR, LS LNR, and then I just need to do ASR. Else shift equals, I've written structure there, that should be str. And this should be ASR. Looks good. I need to fix up these ones so they're not sure. Build. And then hopefully this should fix up our, not too bad, that's okay. Now just give me, dump that so we can see the output. Oh, in capitals, ooh, look at this is doing well. I mean, it's not exactly the most efficient, but then we can fix that up at another time. Or it could be done differently, or something else. Either way, it's what what's implemented that matters. I think this should look pretty good by comparison now. We should be very close. Yeah, so more things are coming out exactly the same now. Why are these ones different? Oh, that's the CS-HS difference. Yeah, it's fine. Oh, that's coming out exactly the same. Right, this is all. I'm pretty comfortable with that. I will go and move that into the right place. Move. What's it? Actual to be expect debugger star dump I. There. Alright, so that test should now be passing. Just check it. Cool. But by capitalizing that, I may have then broken some of the other tests. Somebody has just asked me, what text editor do I use? I use a text editor called Sublime Text. It works well for me. Most of my colleagues at work use Visual Studio Code, or occasionally one of the other Electron-based editors. Some people still seem to like the JetBrains editors. I can't remember the names of them, but there's a lot of them. But I don't get on with those particularly. But that's just me. Again, I'm a little weird on that. Let's commit this actually, and then I can go and check the others up. Change the LSL. Shifts did not. So that's good. I wanted to do. So Livio said I prefer it a bit simpler. It's not just simpler. So this is my one of my windows. I currently have many windows open on different projects. And one of the things that is very common with Visual Studio and IntelliJ and Intelli, whatever the other things are from JetBrains, is that they're based around single projects. You work on one project and that's got all the bits related to it. Whereas I'm working with the operating system, many different modules, many different, like there's a few hundred modules that I'm working with. I'm working with Python, I'm working with Perl, I'm working with things that are not known to Visual Studio or others. So because I'm jumping around things, I don't tend to have want to have the big mass of that Visual Studio Code and the like are. I mean, I don't know if I can pull this one up. So is this one the window I was thinking of? Oh, there we go. It's moved out of the way. Give me a moment. Sorry about that. This is my RISC OS Pyromaniac window, and this is the scroll bar you can just about see here for the files that I've got open. And so these are the files that I currently have open in this one project. And there we go, we've actually hit the source tree now. Oh, and it's stalled. There's a lot of files open, and I search between the moving around a lot. And then I've got a whole load of other windows that I keep open. It has worked well for me. I've also designed a number of syntax modes and other extensions for the editor that are more suitable for me. So that's just how I've been working on things. Other people they're fine to work their own way, and these days I do not get involved in editor wars. I do like to say, oh, I would do this. I've been very impressed actually with seeing PyCharm has been really nice. My previous company, there were a lot of people there who liked using the built-in AI functionality, but I'm a little bit old and I've not quite got into the habit of like building AI into part of the code flow that I have. I tend to find that whenever I've used things like AI and just searching for things and finding a small snippet, it means that I don't understand the general case of what I'm trying to do. And so AI and tools like that, even the code completion, I've turned the code completion off in Sublime, mostly because if I use it, I start typing and it's doing all sorts of things that I'm not wanting, which is very weird. But I find that you don't learn as much about the system. You may get the actual results, but you don't necessarily get you don't get yourself understanding it. So when somebody comes along and says, why is it doing this? You're like, oh, well, that was the code that was generated. Okay, fine. That's how people work. And a lot of people vibe code like that. That's just the way things are. Not the way I want to do things, though. Right, where was I trying to go? I built this bit that's got this on here. Right, I was committing things. I've committed that now. So now I want to go and run all the tests to make sure. I could have done that whilst I was talking. To find out whether there's other things that are broken that I can fix. Oh, whilst I'm doing that. So in nice to see it turn up in your recommendations. It's surprising, actually. I mean, I've been doing this for a few, 15 weeks or something now, and the number of people that have come to the channel to this particular set of sessions from recommendations is interesting. Yeah, I do it every week, so maybe there's more chance of it turning up in people's feeds. I'm just glad you're interested. If you're not interested, move along. There's so much on YouTube. And I've forgotten what I was doing. Memory of a goldfish. And it's getting hotter in here again. Let me just push this window again. It's very hot and humid in here. But we're coming to the end of this session anyway. I'm just going to see if I can fix this one thing, which was... What did I say I was going to fix? Oh, yes, I wanted to fix the test. The test debugger, the one that does init store. Init store. Ooh. Yeah, here. So I think this is taking too long because it's got too much memory being used. App size 200k. Let's see if we can make that work instead. Because I think if we give it less memory in the application slot, it won't take as long, and we should be able to execute that one without it failing, which would be good. There was another one earlier on that failed in an odd way that I was... Oh, that's right, yeah. Memory module space replacements. I think that's the one. Module space replacements. There we are. Oof. That was a window slamming. Right, got something in the way now, it won't slam so much. Yes, like and subscribe, way! No, I try not to do those things, but yeah, do. Just if you happen to like it. If you do happen to like things, then why not? It's all quite interesting. I can't remember what this is. I think this is a system heap. I'm going to put it as HHH because I think that's system heap. In fact, what I'll do, pyrodev list memory. I think it's list memory that shows me what the memory map is. Here we are, yeah. So 41 something. Oh, that's the SVC stack. And then the system heap is just above that. So that's only from 9 to a very big number. But yeah, so I don't need 0 to 9, 9 and A to F. That should do that. Okay, that's fine. So I'm hopeful this will then tidy up some of our tests. Go on, let's run them all, see what happens. Whilst the tests are running, because they'll take ages to send to the server and then run and then bring back. So what have we done today? Today we've fixed up some of the instructions. So well, that didn't work. Why didn't you do that? I've just written in there the right thing, surely. I'll stop it. 041009. Oh, sorry. Yes, that's 9 and then those are 3 digits. Okay, fine. Yeah. So yes, we fixed up some of these tests here, the memory tests that had memory I tests that were misaligned. We fixed the MOVS, RSBS, EOS, and all those, that family of instructions. They're all now coming out the same as in the other places. We've got some better handling of things like the STMIA, so it actually includes the writeback. Most of these cases were cases that were implicit in the instructions and they weren't captured into the environment, the table-based decoding that was used in the disassembler code. So that's been fixed up. We also did some investigation to check how things looked in RISC OS 5 to see if they were slightly different, and yeah, they're a little bit different. Not the end of the world. And what else was there? Was the recent bit, which was getting the star dump I of Hello World working, largely by adding it into the sources. And then LSL, LSR, ASR, ROR, ROL, the shifts anyway. This is looking good. We've got some nice OKs out of this. I'm happy with that. Although I think these were all working already, so maybe I shouldn't be pleased with it. It's fine. We'll let these tests run and see how we get on, and then I'll commit the changes and we can finish the session. It'll just take a little while to do. Gosh, it does take a little while to do. Oh yeah, there was this utility module one. That the unaligned addresses, that was the one, yeah, I did mention that at the beginning. Oh, that's still coming out wrong. That's because, yeah, that's because it's decoding basic trans in here, and it's not what I was expecting it to do. I'm a little bit surprised by that. I need to look into what's going on with it because it's something a bit odd. But the actual difference it's showing up here is not the module, it's the capitalization, which is the thing I've just changed. Oh, and the RRX has not done its thing. I need to fix RRX. I can do that. I'll do that later. That's one I'll fix up later. Let's just try and get this lot out of the way first. Yeah, that's got a thing on it as well. That's good. More OKs. I think we had 15 OKs when I was looking at it last week. Oh, that completed and it didn't crash. Oh, it didn't crash because I gave it the wrong command. Oh, I put single quotes around it. Single quotes aren't supported. Oh, that's annoying. Right, maybe I should get it to generate warnings if you do that. Cap size. Double quotes. Double quotes. Bother. Okay. And these ones are coming out with differences purely for the number of spaces, which I could probably fix up and make exactly the same. Oh, the LSL isn't being fixed up on MVN. I did say MVN should have worked, didn't I? Here we go. Let's go and add MVN to this mnemonic list. MVN. And whilst I'm changing that, we can also capitalize it. And capitalize. Dear me. Which is the same as this code. But for RRX. There we go. So that should now fix the RRX ones as well. Slight difference with the MVN CMN there, yeah. Okay. How is this going? So yeah, some shifts. If I could put 2 extra spaces in there, this would make it even easier, wouldn't it? I could do that. Can I do that? Just 2 spaces, that's all it needs. 2 spaces. There we go. Hi there, Anchor. Not bad. We're just finishing off checking the test results and seeing how things are. And it's looking pretty good, I think. Some slight differences here and here. The table back dispatch index here. This is looking nice. The differences are tiny now. Really tiny. Why did that? Oh, CMN. CMN is also an instruction that can have an LS the shifts on it. So let's do that as well. There we are. Okay. So that'll get fixed up as well. Extra spaces. Not dealing with status register at the moment. And those have just got differences in how the ranges are handled. Floating points. Interesting. Differences in case here. I'm not going to worry about that right now. Yeah, I'm not worrying about those ones. Not worrying about those ones. These ones I probably want to worry about later, but right now not too bad. Passes 20, much better. Let's rebuild it with the little changes I've just made. New status, I should be able to see some of these I can move. So I think this one can go as well. Init store's now working, so that can be put into the right, that can be made the gold master for that. Cool. Both of those. It's still live, I'm afraid, yeah. Yeah, I'll be finishing in a little bit. I'm nearly done, I think. Unaligned. Unaligned. Yeah, I think that one I've done. And yeah, I think those are most of them. Right. I'll just do a very quick run of some of these and then I'll go and merge it. And we'll be happy because I think Oh, that one I didn't fix up. Okay, I can fix that one up afterwards, it's fine. But we should be getting some okays out of this now. But we've got 20 at least, which is nice. So very tediously slow. In theory, if I could run these in parallel, that would make things better, because I could run them on different servers. But I'm already paying a load for the servers, so I don't really want to be... Actually, it's not so much the servers I'm paying for. The frustrating bit is paying for the load balancer, which is the bit that costs... The load balancer costs about 50% more than the machine that it's load balancing for, which is quite irritating. But it doesn't just load balance, it also terminates the SSL. And I could do this all with Let's Encrypt and the like, but I haven't had the energy to do that and set it up that way. The difference between doing things for yourself and doing things at work. If I was doing things for work, it would get sorted because it would be starting to cost more money. But I'm doing it for me, and it's like, I know it costs money, but I'm more interested in doing things that are interesting. I'll put up with that extra 20 quid a month, which I shouldn't, and I should go and fix it, but yeah, I really should go and fix that. It's a bit more tedious. Arctic says, how's it going? Yes, we are really just getting down to the test, checking the tests are working now, and they are, which is good. Is this project on GitHub? Yes, it is. That's a very good question, and whilst we're waiting, I can show where it is. So here is the main project. This is the actual debugger. What do you mean error? Try again. How weird! YouTube just said error. Try again at my giving you the URL. How weird! And there's a task board that says what we're trying to do, which is that board, and the actual DARM repository, which is the one that I've forked to do this work on, is this one, and that does the thumb decoder and the ARM decoder. And the armadillo decoder source is this one here. I can't find it at the moment there. And that does the ARC64 code. Right, I'm looking at this and I'm seeing lots of correctly capitalized things, which is nice. I like correct capitalization. I can fix those, and then we'll be those will be set, and the tests will start to run and pass. I had hoped today to get this finished and be shot of it, to be honest, but I haven't. It's got a lot of the way, and we've got through a lot of different tests. Oh, that's hardly anything different. What was different? Oh, I changed the spacing, didn't I? I changed the spacing, so it's got a very slight, tiny change there. Cool. At least it's fixed. And then, yeah, I was hoping to get it finished, but it's just taken a lot longer. It took a lot longer trying to work out which of those instruction types went into which tables inside the switch statements. Quite complicated in the thumb. And I'm still not convinced the thumb is right. It's still giving me errors for the app size. Oh, no, it's not. No, it's actually coming out right. It's saying initialized with this. Whoa, excellent. So that is now fixed. Init stores are now working. I'm feeling very confident with this. Hello, Prem. We're just testing the last of the code that was being run. This is all known to be failing down here, so I'm going to ignore most of this. In fact, I'm going to stop it because there's no point in running those. So, git status. Which of these can we say are good now? Thumb code. Yep, that one was finished. That's now good. Init store ones, both were passing. That's good. No, well, not passing. They were in a state that they were working, which is what we wanted. And init store, the other one, that one. There. And dump I was also fixed. Of that. And the other one that I'd fixed was the none. Show regs none, that's it. Actual goes to show regs none. There. Alright, status. Lots of things fixed. The main part of this is alignment and capitalization. Yeah. Alignment, capitalization, init store, and show regs tests fixed. Alignment of some comments was inconsistent with Pyromaniac, oops, which has now been harmonized. Capitalization of the shifts are now fixed in test expectations. Init store now uses less memory, so does not hang. Show regs tests are now fixed with a replaced address. Oh, nice. Push that so you can have a look at things if anybody wants to. And let's just make sure we can build both the versions, both the 64-bit and the 32-bit. Well, I wonder where that's coming from. I'm in the wrong place, that's why. I think I must have left some debugging inside ammo. Oh, that's wrong as well. Let's go ammo minus F. Build 64. Discuss. Ammo. Make module. Yeah. Since it's still using minus OZ. That's not right. I thought I'd fixed that, but maybe it hasn't yet been pushed. Okay, it works. Well, it builds for 32-bit and 64-bit, so I'm happy with that. Okay, we're now done for the day. I may go and push the code into the RISC OS 64 status repo, but I think that's everything. Yeah. Thank you very much for watching. Hope you've enjoyed it. Next week, more tests, it looks like. We got a lot of them done, but we were on 20. I think we're up to maybe about 24 now. So there's probably only about 10 left to sort out, and most of those should be quite simple. Fingers crossed. All right. Have a good afternoon, and we'll see you next week if you want to come along. Bye.